Yeah, as we can see that how to train is the model is loaded with the data. As again, I'm taking the iris datasets, and the data is viewed in the data table. Then the different models will be trained the given data set. Then those things will be given in the prediction table. Up to this one is a training, whereas for the testing, I have used another iris test data set. I will show the test data set where iris iris test data set. Yes, this is what the iris test dataset. I will show the iris original dataset as well, so that yes, this is what the original iris datasets, which is provided by the orange, where there are four columns. One is sepal length, sepal width, petal width, and the classification label is called iris. This is called row 2 is called metadata, where C is denoted as continuous values, whereas D is denoted as discrete values. So all the features are given in a continuous values, whereas the class label is given as discrete values. So the discrete class has three distinct classes. One is iris etosa, iris versicolor, and iris virginica. Initially, the model is trained with the iris original data sets, and for the testing purpose, I have created uh, the sample data sets where I have given some random features values and the class labels. So these are all the expected prediction classes. So with our trained model, once I fed into the new testing data sets, we can see the prediction. Let me close few things. This is what the prediction results. If we are using a tree model or logistic regression, navy base, or in the neural network, which one we are using? The prediction, the green one and the red one is showing that the iris will be misclassified. There is a misclassification in the data sets, so that those things will be given. Where here the important things are the parameters called uh, area under curve, classification accuracy, F versus precision, then recall, from in which if once the model is trained with our testing data sets, the tree and logistic regression are the two models having the more accurate results than which is 92.6 percentage. So this way we can train a model, and we can use the different data sets to test a model. Then based on the results, we can find the which model is the best suitable one. Then as I explained above previously, that model we can either way we can save the model and we can use it for the future purpose. Then next one, I will be opening visualization user defined datasets. To do the user defined datasets, what we can do is we can simply do one thing. We'll simply take one file with few tab separated columns. That value will be anything. So if I'm having given two 2, 3, 5, 6. It is simply I'm just using few data sets of any kind, where to define a single data sets, the primary thing is the column which we have seen here, the meta columns, which means the CC and D, which denotes whether our data sets types. For example, if I am giving these four columns are continuous, of column, let's say, let's convert it some meaningful informations, like let's identify uh, what, let's take height, weight, and we can take age. These three are the distinct. These three are the columns. Then we can try to identify something like what we can identify with 125. And weight is 145 kilos, and the age is 18. 173 and 60. The age is 20. It is 146. And weight is 68 or something. We can have a class called his whether obese or not. I'm just for the sake I'm giving simple values, whether it is not accurate or it is not going to predict anything or meaningfully. But for to compute the user-defined class, user-defined data sets, how we have to do is we have to take the data and we have to define the meta attributes for that. So for that sake, I'm giving as if it is yes or no, or we can use yes. This one is it's a different data set. Okay, I'm just going to load our user-defined data. It is in desktop orange. Okay, already we are having sheet one. Okay. Oh, it is the previously I have created one data set, that one, not this one. User defined. Okay. Yes, it is showing somewhere. Okay. I'm just explaining the previous one I have used, where it is nothing but it is having four features called height, weight, eyes color, and hair color. With that, we are going to predict whether gender is a male or female. That is what the datasets previously I have used. So since a dataset I will show you guys. User defined datasets. I don't know where I have kept. So I just don't want to waste the time. The thing is, if we are giving the data set like this, we can define like this. Then we can it will automatically few times if you are not giving any uh, columns like category tables, which one is the target variable, it will automatically identify based on the data sets. That's what I'm trying to say here. uh, so this way we can load our user defined data sets. Just go some fast. Train and this workflow is for train and test is already train and test we have seen. We can go for classifier predictions. Okay. Student score is also the same thing. Starting classification. I'll just sorry for the delay. Just taking. I have missed something to clarify, but I'm checking where I have missed. Already in your classifier. Okay. Let me explain the things which is perfect as of now. Okay. I will show the image classification first, or image clustering. Here, what we will trying to do is we are taking the domestic animals as a data sets. I will show you the domestic animal data sets which we are having. Okay. This is the data sets where we are having around 20 images of domestic animals, uh, which within by using this one, we are trying to classify them into the groups. So for that, I have used image embedding. As I have shown previously, image embedding is a widget used to get the images as an input, and for the image viewer, we can able to view the image whichever we have taken. Then image embedding. Image embedding is a feature selection matrix from the image. As I shown in the morning, whether I can use Google Inception V3 or any other SequenceNet image classifier to fetch the image feature matrix. So once the matrix is fetched, then that matrix will be fed into the distance matrix, where distance matrix will used to identify the similarity and dissimilarity. Then that value will be fed into the hierarchical clustering. Then that will be given to again. I'm just opening the cluster C1. I can view this. The cluster C1 is see with cluster C1, we can able to see the similar domestic animals with having two legs, right? So if which means these groups are uh, classified with more intra similarity. Whereas if you take this C1, these two also, these three images also having two legs. So but the difference between these two are, these four images are in yellow in color, where these three are where differ. Whereas if you take all this one, these are all in two legs. So which is more meaningful, right? Whereas if you take this one, it is all kind of four-leg animals or something. Whereas if we are taking all these two, which have two legs, so this if you take this one, these two animals are so it is classified in a way that based on the features from the sequential net. Whereas if we are using inception v3, again the image embedding will happen and the results will be populated. So here also mostly the see where here hello ma'am. Uh, is my screen is visible or it is not visible for somebody? Now is my screen is visible?
Yes, sir, your screen is visible, sir.
Ma'am, here the problem is we are opening a different screens at a time, so probably that is the reason it is very
Okay,
small in size.
okay, sir, okay.
You know.
Now it is working, sir.
Okay. So the thing is, previously we have used other image embedding technique where the cluster C1 is formed with uh, two legs, whereas if you are using the Google Inception, it is classified four legs in the first cluster, whereas two legs in the second clusters. So same way, each embedding technique has its own feature extraction method, so that according to that the distance or similarity patterns will change and the hierarchical clustering will be changing. So the basic for the classification is before to classify they have to compute the distance. That is the basics. So even if it is a text or image or a data set, everything will be computed with the distance. Based on the distance it will be clustered. So in this way, if we are classifying the clusters, so if you want to do the same thing with what we can say, is it clear? Hope how the predictions work is explained. Is it okay? Could you please anyone confirm whether my voice is audible? I think for me it's disconnecting somewhere. So
Sir, your voice is audible, sir. No problem.
for me it's keep on disconnecting, ma'am. So whether this graph explanation was given,
Sir?
this graph was explained. I think it was frequently disconnected. So I don't know whether it's
No, sir. Now your screen is also visible. Your voice is audible, sir.
okay. Thank you, ma'am.
Okay.
Okay, let me re-explain this diagram again, where in the image classification, we have seen one widget called distance, which is used to compute the similarities between either the image or data sets or anything in the feature sector. The same way, we can use the test and score for uh, compute the for doing the computation based on the predictions. If you want to predict anything, we have to use the widget called test and score, which has to be fed with both the data as well as the model. Then the test and score will be computed based on the model trained. We can predict the things using a different training set. So for the classification, we have to use uh, distance uh, distance widget, whereas for prediction things we have to use for test and score. And for the better understanding or analysis of result, we have to use confusion matrix and ROC analysis for prediction things. So again, here we have used heart disease data sets for the data set exploration. Whatever the data sets we are taking, Orange is analyzing, and it will be clearly giving the details about the data sets. There are 303 instances where 13 features, out of which the output will be classification with two categories, and there is a no missing values in the data sets. If in any of your data sets has missing values, then we have to do the uh, pre-processing thing to remove the missing values. For example, housing data sets, these data sets were collected from US Census Service and housing centers, where 506 instances, it is regression kind of things. So it will be, the value will be numeric classes. There is a no in here there is a no distinct classification. So in if you are giving distinct value to navy base or CNN2, it will throw the error, right? So for this we have to give the categorical input. So if you are giving categorical input, then navy base as well as CNN will be working fine. So in such a way that if we can use the for analyzing a particular data sets, we can use the different models provided in Orange. Then we can identify the best suitable one. As in the morning, I have explained some widget called stagging, right? Stagging is a widget which will be used to identify whether which one is working perfectly. I said there are three different models: neural network model, logistical regression, and Navy base we have used. But is it necessary whether these three only provide the best results? So stagging is a new widget which will take the combinations of any of the more existing models, and it will take the combinations of those things, and it will check whether the combination model will provide the better results. For that, the important widget stagging was used. So in this research, we can see that stagging is provide the better stagging is provide the better results compared to Navy-based neural network and logistic regression. Among the Navy-based neural network and logistic regression, we are getting the better results provided by Navy-based, since once tagging was used, uh, compared to Navy-based, the classification accuracy of stag is more accurate. So, which means the hybrid model of machine learning will be more accurate than the simpler one. That is what conclusion we have to arrive from this graph. Where if we are reducing the folding, for example, cross fold, previously I have given 10. If I am giving 5, then the entire result set will be splitted into 5 different data sets, from in which the values will be recomputed. Then from here we can see that once if the cross fold of data is 5, in that case our stagging, our logistic regression provide the better classification accuracy than the stag. See, so this is what the main play in the, this is what the main role where iterations and the input folding matters when uh, different data sets are used. So to present in our research articles are like this. So comparative study and for the better results projections, for those things we can go with this tool, so that we can get the most feasible results. If we are presented, then that will be more weightage for our research paper as well. So if we are go with random sampling, again the results will change. Again, it will compute the test and score. So here it is computing. It is taking some time. For random sampling, let us see the results. If we are go for random sampling, then our classification accuracy is better in the stack, or not stack. Both stack and navy base are the same, which is 86.1 percentage. So this one is for stag uh, widget and for the prediction model. I will share all these workflows if you want, so that you can just explore it and see the things. Okay, let us go with decision tree. A decision tree is was very simple one, where if we are same thing, if I used iris data sets for to do the decision tree, we have to use the model called a tree. Then that will be given
Okay,
as the decision tree with based on the our gaining index or gaining
மேம்
summation.
அஸ்கர் முடிச்சிட்டாங்க மேம். ஹலோ மேம் அது ஓகே ஓகே மேம். அஸ்கர் மெயில் அனுப்பிச்சியா மேம்க்கு? ஓகே
Somebody's
ஓகே
voice
மேம்,
is
வெரிஃபை
very
பண்ணிட்டு
low.
சொல்லுங்க மேம். ஓகே அஸ்கர் வெயிட், அஸ்கர் வெயிட் ஃபார் சம் டைம். ஓகே
Okay. For K means, I'm just taking the paint as input. I have given two clusters where I have painted some points. If I fed this into K means, here it's a very very important one, which will be provided by orange. Whereas in the K means alga classification, what we will do, we have to recompute the iteration again and again to get the centralized fixed, right? So in that case, there are we are looking either fixed size of clusters or number of clusters varying 2 to 8. If we are giving like this, it is giving the Slaton score, which means if we are taking clusters number 3, then that will be the best cluster. That is what it will do. Instead of doing the manual iterations to compute which one, which number of clusters, so that our all the points will be well separated. So identify that one. We have to use Slaton score, which will be coming as part of orange one. For
மெயில்
example, if
வரலீங்களா?
we are changing the
செக் பண்ணிக்கிறேன்.
data sets,
அஸ்கர் அனுப்பிச்சிட்டானா?
if I am just putting changing few data points here and there,
மேம் அஸ்கர்ல இருந்து அனுப்பிச்சிருப்போம் மேம். முகமது
if
அஸ்கர்.
I change the value, then once if I change the value, the Slaton score will be that if we are putting with 7 clusters, then only our points will be well separately classified. So these are all the 7 different clusters given. So if we are
இது
giving
பாருங்க.
this region, these are all the 7 regions, whereas if we are changing the point, we can clear few points. I'm going to address few things. So I'm just pointing, changing few cluster points. Let's say this. Okay, if this one is my input, then my Slaton score is saying that there should be 3 clusters, whereas the classification is given like this. Actually, these two are the same cluster points. So this is the let's what we can say. This is the one of drawback for the K-means clustering, where if we are taking the compact points, which means the points on a group, then it will be classified correctly, clustered correctly. Whereas if we are giving unorganized space here and there, which means more outliers are there, then we are not able to clustered in an efficient manner. So to overcome that one, we have to use for iterative clustering. Let us explain. This is one more visualization graph where MDS, where we can see this how the points are interlinked in the network model. So how the centroids are connected, that we can see it in the MDS graph. From the regions. So these are all the things we can change. see randomized point it is. So this is about k-means. As I said, to overcome the drawback in the k-means, we have to go for iterative k-means. In the iterative k-means, again, there are points were dropped where if we go for iterative clustering, here we can define the number of centroids. For example, if I go with number of centroid to 10 and randomized to positions, and if I give the recompute centroids, it will be recomputed and classified. So I am placing some randomized positions anywhere for the centroid center for the clusters, and once I have given the recompute, then if I run, the cluster will be able to see now iterative clustering. The each iterations, the centroids will be keep on recomputed and repositioned until the there is a no change in the center of the clusters, which means all the data points will be properly classified. So here also the certain score will play a role. This is what the difference between the k-means and the iterative k-means algorithms. To open the another one, we can see hierarchical clustering we have seen. PCA. We can see PCA. As I said, to do the predictions, there are two things. Either if there are more number of let us say more number of features. Let me take housing. There are uh, 13 features, right? If there are 13 features, we have to identify which features I can take so that my classification will be more accurate, right? So if we are using the principal component analysis, what it will give is a number of out of given features, which number of features we can take so that it will cover the maximum number of points under the curve, so that it will be if our points are if our graph is taking more number of points with less number of features, that way we can choose those are all the important features. We have to use those features for the classification, right? So for that only we are going with principal component analysis widgets. So the same thing we can there is another widget called rank. Morning I have shown the same thing. Rank is a widget which is taking all the again features, and it will be compute the gain and Gini ratios. So within which it will give that these are all the prime features we have to use for the classifications. So for the ranking algorithms or for the predictions, either we can use the PCA or ranking methodology to get the features before instead of taking all the features in the data sets. We can for example, if I'm taking housing data sets or zoo data sets, there are 16 features, whereas 13 features in the heart. Brown selected a gene expression. If I take this data sets, you can see there are 79 features in it. So out of 79, I have to what is the it will be better for the algorithm. So here it is giving this, if we are taking 7 components, which will be given the better results, because if you are go with keep on going all the 19, you will get 100 percentage, whereas if the points are very much varying, but if it is 7, the percentage also more than 75, and if you are reduce it also, it won't work much better. Even if you are increase it more than anything above 7, there is a no drastic improvement in the performance, rather it is has a mild fluctuation. So it is we can from the principal component analysis, we can say that if we are using the 7 or 7, then we can uh, take those predictions. See, here in the rank, we can say that what all those 7 features let us compute. So it is based on the information gain ratio or whichever model you want to choose. If I'm choosing information gain and information ratio, which is very important for the tree classification or tree regression. So for that, I have used these two methods, and I am going to find based on the PCA. I came to know that there are 7. If we are using 7 components, which is yield the better one, I have to find which are all those 7 components. I have used the rank method to get all those 7. Once I got those things, I can go for column selections. I can select those 7 columns for the features and the predictions and the metadata. So among which, what are the 7 columns I have chosen, which will be given here. Only features to the features. If I choose input feature, see, previously all the features will be selected by using the select column. I am using the rank method. What are the columns I have identified, which will be fed as a feature to the feature, which means features in the rank, those 7, which means in the rank I have given best of 7 only selected. So those 7 features will be those 7 columns, and it's a targeted column only will be taken. So this is the way. If we are seeing it in the data table, our data set will be reduced, which means previously our data set is like this. There are 79 features, where among in which we using the PCA and rank algorithm, we found that 7 are working fine. So with that, I have split the data with these seven columns, and those will be taken as always select use always use input as features. Then those values only displayed in this modified, let us say modified data set, which will be used for the algorithm to work the efficient prediction and classification. So this is the difference between, this is the way we can use the rank and evaluate metrics to identify the classification levels. Prediction widgets, rank, text mining. Okay, let's go with our text mining. Instead of working with normal text data data sets, we are going to work with some documents. Let us say corpus. Um, Here again, it's like a widget for a file widget for dataset, image widget for image classification. Likewise, for the text, we are having the corpus widget, which is taking the documents as input, then those documents will be uh, pre-processed or using these widgets. For example, if I'm using the word cloud, what is meant by word cloud? Word cloud is nothing but a number of words and its weightage in the entire document. For example, initially you have to see what is my all what are the documents in my corpus. So I have used corpus viewer. Here I have given there are 139 documents, different documents, uh, and its content. So let us take. We don't know what is inside the content. So we have to identify what are the those documents are trying to say, or what these documents are trying to uh, talked about. So for that, if we are using the word cloud, from the word cloud here, what it will do is the letters which are all bigger has more number of occurrence in the document. So the letters which are all very small has the least number of occurrence in the documents. In which means, in finally we can come to know that the word which has bigger size has the more number of usage in the document. So we can ideally say that this document is spoke about a particular word in the document. So if we are using this one, can we able to say something? Because all the words over here are punctuations, unwanted things. Let's say punctuation or uh, that is what we can say, wow words or some meaningless. So we need to pre-process it first. So for the pre-processing, we are using the widget called pre-process text. For that, initially we have to convert all the letters into lowercase so that we can what we can do so that we can there is a no mismatch weight mismatch between the uppercase and the lowercase one or capitalized one. So ideally we are do all the documents to lowercase, then we are removing accent. Accent will remove like accent word like oh ha something like. Then parse html, it will remove all the html or link relevant components and remove the URLs. It will remove everything, and we are going to only take the words, not the white space sentences or anything. Then once this one is given, let us see the word cloud. See the word cloud here. These are all the two different word clouds. We have received before pre-processing and after pre-processing. Before pre-processing, we have seen the question marks or us at something like this. Whereas here, some words were removed, but still it is holding the words like conjunctions or prepositions. So so we need to remove those things as well. For that, what we can do is we can remove the stop words. Stop words are nothing but these kind of words we need to remove. How we will do? We can choose the language. This is very very useful when we are working with mm, uh, natural language processing. Here we are using just English, so we are going with English where we have to remove the stop words. What are the words you are find its conjunction or preposition, or what are the words we need to remove? If you found, you just type all those words in the any notepad. You can feed it here so that it will remove those stop words. Let's say I am having few stop words here. Let me show what are the words here. See, I have given could, would, should, should, went, uh, said twice, go, came. Likewise, I have given a few stop words. These words, I'm thinking that these are all words to remove from the word cloud or pre-processing. So I am using those words to remove that one. So once I have given the set of words which I need to remove, then now we can see our word cloud. See now our word cloud has much more fine tuned, but still we are not able to identify the documents or what the documents are meant by. But from this word cloud, we can find that there is word called man, girl, woman, or something, right? People. So still, if you are remove all the stop words, then you can able to identify exactly what the document is talked about. So here in the word cloud, here is in this way the word cloud will work. It will identify each word and its weightage. So based on it will allocate the size. The one is the one has the highest size. So bigger one. So if the word which has least in occurrence has very less in size, this way the word cloud will work. So let us take an example. Once the word cloud, let us take one document. I have a set of documents we have taken. We have pre-processed. Then pre-processed data will be given to backup words. Backup words will be used to identify. Let's just say it is kind of feature extraction we did in the image embedding. So if we are giving backup words, it will do some manual engineering process, and it will uh, what it will do, it will give the some meaningful corpus. So from that we can go for the training and testing model, or we can go for distance. Yeah, here we can see the both clustering and the classification in a single method. For example, here I am taking the backup words both for testing test and score, which is used for prediction, whereas distance, which is used for classification. So both the things I have taken. Then this one will be trained by using logistic regression model. Then the results will be given in the confusion matrix and the corpus viewer. So this is where it will be classified. For example, if we are taken four documents are pre-processed, and from here we can find those documents are similar. So same way, if we are compute the distance from the back of words, then we can able to generate the hierarchical clustering, where the clusters, each clusters saying about, see, the documents are grouped together, animals tables, and here tables of magic. So these are all the groups, these are all the group of documents are given as part of this one. So this way we can do the clustering and classification among the documents as well. So for that we have to, for that we need this text mining category widget. It will not be come as part of initial orange. So we need to download, we need to do the add-ons manually, as I shown in the morning. With administrative privilege, if you are opening it, here it will come the text mining. So you can download it, you can select and download. Once download is done, you have to restart, and it's very good to go to use it. Um, Let us say a few more things for this. Let us say Wikipedia search. Okay, for the Wikipedia, I'm giving. You can see some. I have given Excel Engineering College. Let us take a few documents from the Wikipedia which contains Excel Engineering College. Okay, if I'm searching, it will fetch data from Wikipedia. Let us use ACT. I'm just giving less number in order to get uh, better results faster. So I have given AICT with five documents from the Wikipedia. Let's see what it is giving. Meanwhile, we can open it here. Wikipedia search. Here, AICT Wikipedia search. Yeah, if we are giving AICT Wikipedia search, what are oranges doing? Let's say we have to see word cloud again. At least from this word, if we are pre-process it, let's say pre-process text, lowercase, remove, stop words. Yes, once it is pre-processed, word cloud, the word cloud, yes, we can see this is educational, engineering, technical, higher national council, uh, grants, institute, department, resource, students, literature. Okay, this is the way we can either take the data from Wikipedia or we can get from the Twitter data. We can pre-process it and we can give it to the backup words for either we can go for prediction or classification or we can do all those stuffs. Okay, this is all about text mining or text classification and clustering. Text import we have done, predictions, classifications. Yes, but final, last but not least, we can see orange tool for COVID. Okay, let's see COVID data set for orange. For COVID, uh, as we know, to get the live data for COVID-19 or pandemic results, we need some dataset providers. As we discussed, uh, I I got one dataset providers. Uh, let's take like this raw data. So it won't come. I have taken data from the university which providing dataset. GitHub. Yeah, either way you can go with the datasets provided by Johns Hopkins University. The university has a COVID dataset which is updated regular basis. Uh, so if we are taking the live datasets from them, for that I have taken that URL, this URL. The URL has the uh, data up to yesterday. It is got updated, so I have taken that data set. From that data set, uh, to always work with the existing data set, I have shown the warning. There is a widget called a data set which has all the data related to either a country or confer cybersecurity or for different things. There is an already data predefined data sets available. So for work with COVID dataset, for the better classification and better visualization, what I have do is we can take the human development data, which is already have a set of meaningful features about the human. So here also we are COVID also we are seeing those data as number of people affected by COVID. So I have used the HTA data set in order to merge those data sets because in the COVID data sets you can see only the values with all the countries and number of entries for each date. So it is so in order to make some meaningful projections, I just used HTA data set uh, from in which what I will do is I can just uh, merge those two data set. So in the merger I have given uh, the data will be merged with countries and its region. So instead all the countries with values I have just given some country and region and country wise. So if I given the data set will be grouped with each country and its region wise. It will be grouped. So what we will do is we are selecting from the data. A few countries have inadequate data, like they are not given anything related to population index, number of people in their country. So in order to eradicate such outliers, I have used select row function where I have chosen only the countries given uh, population details. So which is at least greater than zero, whichever population countries giving the population value greater than zero at least has some meaningful information. So I'm just fetching only those rows, and from that I have get the feature extraction. What I did in the feature extraction is I just get the values and divide its number of millions, so that our projection uh, uh, will be very easier for us. Otherwise our projection will be very large, so we can't able to so here also we can say that yeah, there are more number of projections or features. We have to identify if we are using which top projections will give the better classification and better visualization. For that, we can use options in the scatter plot, find informative projections. So I have used that one, from in which I have chosen case per million, gross national income. So these are all the some features. If we are taking to project, it will give them some meaningful projections over our data. This is all about actual data will be taken from here, which will be merged in the HTA data set so that it will be normalized. Once it is normalized, we are selecting only few rows, which means the countries which have population entries, which will be fetched. Those from those entries, we have extract few features. Then we can plot the graph, right? By seeing in the scatter plot for COVID is not quite interesting. So what we will do is we can see those entries in the map, right? So what we will do is again taking the same data set, and I will connect those data into geo map. Geo is again an additional add-ons we have to do in the geo add-on. Can we have any doubts how we are mapping those data with geo? Yes, the answer is in the data sets they have provided. they are having two columns called latitude and longitude. With that features, we are just mapping all the data to the geomap. So from here we can see sample size of different dates. For example, the circle which in the bigger one shows that US has more number of cases, United States has more number of cases compared to other countries on a particular date. For example, if current date up to yesterday, or let's take 17th. Yesterday, up to as per the record, yesterday US has the highest number of counts. Then India, then here. Whereas if you are seeing in 10, 16, 20, 20, both India and US has almost same numbers. So these are all the way we can visualize the real-time data with map widgets. So this way we can reimagine. So if we are see it at the peak levels, see China was highlighted. Initially, China has the more number of COVID cases. So like this, from China, it is went to Italy somewhere, right? So it is spreaded somewhere. So it is showing like this. So we can see the real-time data some in the geographical view. For us, if you want to see it like not uh, graphical representation with the different color with aggregate totals. So based on the sum of entries in a particular date, the highest region will be highlighted in yellow, then with green with zero, whereas yellows are showing that it has more number of cases. Is it? So same way, if you go for China, initial dates, China has the highest cases, whereas other countries has no cases. See, India has 0 to 1, whereas China has 547 to 1092. So likewise, from the real data, we can able to predict. Whereas it is started spread, yeah, it is spreaded over America. So as of December month, India is between 8,000 to 10,000. Okay. This way we can visualize the values, and for this we can how we can go for predictions or classification. Yes, we need to do some column selections, some transpose matrix, and because this data is since only time range, we can't it is not giving us mm, actual, it is just consider our data set will be simply consider this as a value. So we have to say the system is, it is not only value, it is a time series value. For that we have to expose, we have to select few columns, we have to remove longitude and latitude. It is only useful for geographical things. So I have removed those two, and remaining columns will be transposed. Why? Because instead of having countries here and dates here, I just want to see like this. Whereas each country wise and against with each data, each date. So I have transposed the data, and the edit domain. Here I have changed. Previously, it was like data. It is a numeric value. Now I have changed it to time series, so that only it will know that it is a time series data. Then the time will be given to time slice. Then I have transposed, and I have the comparison results of each dates we can give. If we give the informative projections, again we can See, this will give the different kind of projections over different sizes. This way we can do both the both the visualization as well as the clustering and classification things. Um, as of here, I'm just going to end up the things. If anybody has any question, please.
Participants, if you have any queries, kindly ask. So no queries from participants, is it? Sir, shall we conclude, sir?
Oh, yes, ma'am, sure.
Okay, sir. So today, sir have explained about and show the practical on Orange tool and how to extract the data. Thank you, sir. Thank you for accepting our invitation to be with us today. And also, I thank the participants for completing this today's session in successful manner. Feedback link is given in the chat box. I request the participants to give the feedback without fail. Still, few participants haven't give the feedback for yesterday session, day 4. I request the participants to give the feedback for day 4 without fail. No queries means we will end the session. Feedback link is shared in chat box. Kindly fill the feedback link.
Thank you, ma'am. I'm
Okay,
leaving.
okay, sir. Okay.
Thank you, ma'am.
Thank you, ma'am. Okay, thank you for all.